Um, this is Wolf Point Creek. We've studied this the most time. This is named after Don Lawrence Lake, so it's only 3 kilometers long. It's up here. But we also have a Space for Time series. So I first met Greg in 1976. I always tried, when I do research, I always tried to have a one-on-one with him. And he was very wise and gave me his wisdom about stream succession. But I also have a walking stick that he carved in Kenai with a stonefly nymph on the head. That's great. So, the UK always forms expeditions. So I first came here in 1977 with 8 people, 2 cameramen and a cook. It was easy. And we looked at Space for Time series, of chronological sequence. So we were sponsored by National Westminster Bank, and we tried to take photographs for promotional sequence. But look at the, you can't see the National Westminster Bank because all was... And then the Mercury gave us the motors, but we put it upside down. We had a problem with it, so this was what it was like, the icebergs going from Nunatak Cove to Wolf Point Creek. So initially we looked at a time chronosequence. This is our youngest stream, Stonefly Creek, and this was our oldest, Rush Point Creek, about 200 years old. So Sven did a lot of diagrams in his thesis. So Megan Clark gave a talk last year, and she was responsible for this. This is the different habitats that are in a stream, and Wolf Point Creek, the youngest, or next to the youngest, had just riffles and glides, or runs. But the oldest stream, Rush Point Creek, had pools and glides, so more diversity and habitat. And you can see that in Berg Bay South. So Wolf Point Creek, we've studied that the longest time, and initially you can see the interstitial stumps here at the base of the falls. So, but it was very turbid and very cold because it was flowing from the remnant ice, only maximum of 2 degrees. But it became, with Lawrence Lake, it got a lot warmer, and it was maximum of 70 degrees in August in 2001. So a turbo cold stream to a warmer clear water stream. So this is the vegetation. Initially it was able to walk along, it was just stony gravel and a few dry ice mats, but then in 1998 scale here, it became riparian vegetation, and now you can, it's become a cottonwood forest with a few spruce. So. Terrestrial vegetation, when it's connected with the stream, supplies a lot of terrestrial invertebrates for the fish and positive feedback by intercepting runoff and making the stream channel more stable. It's a primary successional sequence where no previous community existed. So it involves aerial dispersal for aquatic invertebrates to get over the mountain barriers. So aquatic insects have a distinct advantage. So Connell Slater proposed 3 mechanisms of succession and facilitation, which is the classic glacier-based vegetation sequence. Terry's going to talk about this in innovation. But tolerance is one mechanism. It involves established species exhibit a professional tolerance of invading species. And there's very little literature in the literature of tolerance being an appropriate model. But tolerance works. But this is Moore Point Creek, and most of the species have existed, and they tolerate the existing species that colonize. So we thought it's one of the few cases of tolerance in the literature. So this is, if it was stochastic, the points would be down here, but it's deterministic to begin with. It's pre-described because of the cold water temperature. Only a pioneer colonizers exist, and then it goes stochastic over time. The main thing is salmon colonization provides a big kick point to the invertebrates in the community. And the retention of carcasses, especially in the younger streams, is virtually non-existent because they need coarse-woody debris, pools, boulders, and off-channel habitats to retain the marine-derived nutrients that salmon carcasses involve. So, the other effect of salmon colonization is the red digging, and they create a big disturbance to the invertebrate community. Over 10,000 pink salmon colonize Wolf Point Creek now. You can see here, because it's a 2-year cycle, sorry. So it's a 2-year cycle. So these are the increasing pink salmon, and the colonization goes down, the invertebrate community abundance goes down. So, and it increases the relative abundance of black flies and certain chironomids in disturbed areas. So it provides persistence of early colonizers. The salmon red digging does. And then we looked at, rather than sacrifice the fish, we used exhibit, put a needle down their throat and regurgitated the contents, and we don't have to kill them. So, so it's better than killing them. So, and increase in riparian vegetation provides a lot of terrestrial invertebrates, and over time they become more important. But this has not been documented before. Sven Harald did this. Sea lice. Fish eat sea lice. Juvenile fish eat sea lice. But it's not in the younger streams where the salinity is low because of the freshwater input. But it's only in the older streams, Berg Bay South and Rush Point Creek, where the salinity is higher because they stay on, the sea lice stay on the salmon over time. So this has never been documented before. So reset mechanisms of streams by floods. This is the width of Wolf Point Creek before 2005. And then 37 inches of rain fell in 24 hours on top of snow in November 2005. There was a declared emergency in Juneau. So you can see the stream really half the width, and it really deepened. So all the pink salmon eggs that have been laid that summer washed out. So this is the detail of the effect on the salmon, pink salmon spawners. It was about 13,000 red dug in 2005, and then it was 500 in 2007, 2-year cycle. But in 2 generations, it had gone back up to where it was before. So they're very able to colonize. And then the summer flooding, it reduced it a little bit, but it didn't involve the salmon eggs being taken out, the pink salmon eggs. So the 2005 flood reduced the abundance and richness a little bit, and 2014 summer flooding reduced abundance a little bit. And so this is the invertebrate community in Wolf Point Creek. You look at these are years. So you see 78 to 94. And then it went to another community, and then it reset in 2005, 2006, 2007, 2008. It reset the community a little bit, and then it recovered, and then the summer flooding reset the community again. So resets after 2 floods in 2005 and 2014. So, and then the functional richness increases over time, 1997 to 2020. So this is a summary that Dan Engstrom, Terry Chapin, Chris Vasti, and Lewis Sharman published together in Bioscience. I'm surprised everybody hadn't connected the systems before. So we have the terrestrial system, the lake system, the near shore, and the stream succession. And the sediment is very big, and stabilize the channels is very big. So, and then over time, this is 150 years, it becomes a lot bigger, the connection between the terrestrial, the lake, and the intertidal with the stream succession, especially the carcasses coming back up the stream. So this is a paper that we've published in the end of last year, looking at the different filters at different time intervals, and 50 years to 200 years. So initially, the water temperature has a big influence on the vertebrate community. And it lowers through time, because the pioneer colonizers can only survive that trip. So, and then the nearest colony source is very important, because you need a nearest colonizing source for invertebrates to fly over the mountain ranges. So, And then the biotic interactions increase in time, so they're the light blue. So the summary is maximum diversity of habitat seem to be found in mid-age streams, as you saw before. Wolf Point Creek is the most studied that we've done. Yeah, I've only missed 5 years in 47 years. So tolerance is probably the most valid of the Colonization and Slater models, the 3 models. But there is reset mechanisms. Well, salmon colonization is a big turning point in stream development, and the disturbance by red reconstruction has a major influence on the invertebrate community. And also bringing in marine-derived nutrients. And they get hauled out from bears and then enhance the riparian vegetation. But we only found it in the older streams, influence the riparian vegetation. But there is a number of reset mechanisms, like floods, well, climate change, a lot more floods, and November 2005 flood and a series of floods in summer 2014, particularly the invertebrate community and the salmon. And the salmon recovered within 2 generations after the 2005 flood. And we looked at various filters, and water temperature decreases over time, and biotic interactions increase over time. So deterministic to stochastic. So that's the sequence. It's initially deterministic with the cold temperatures. Specifically, pioneered colonizers are available to colonize, and then it becomes more stochastic over time. So I want to acknowledge these past PhD students. I've had 10 study under me, including Sven, and other names have helped me over time. So thank you.